Hello viewers, welcome to Analog Instruments lecture number 4. Today we are going to design the layout for AND gate. For the schematic of the AND gate, we are going to use NAND gate and CMOS inverter. Before that, we need to generate the symbols for the schematics. Follow the below process to create the schematic. To change the name of the instance, we can press Q and change it here. Sometimes when you create this kind of instance and you use it in a schematic, you might get some more extra data on the symbol. In that case, you can use at the rate in before using the name of the symbol. Then you can not get that kind of error. But for now, I am not using it. Similarly, we can create for NAND gate. I actually created earlier, so I'm going to open and edit that. I didn't start the editing. So you can use if you want to create a circle symbol, you can use this, and any create elliptical symbol, you can use this, and the different type of polygons you can make using this option. You can create a line using this and arc using this option. Since here I'm using arc here, you can follow this. This to represent an AND symbol. I'm using this as my NAND gate. So now you can create a new file, that is AND, and while making the connections, use bind key I for the instance, and to bring the symbol that you've been created, go to your library, again you can click I, Now you can bring the CMOS inverter symbol. You can start wiring. And you can create the pins. Output pin we can keep Y. Input pins are A and B. It's input ready, yes. Input. Can give the connections accordingly for the pins. And to undo your action, the bind key is U. You can save the schematic. You can launch the layout. Follow the previous instructions, that is standard height, that is 1.71 micrometers. And next thing is you can select multiple objects by clicking on shift, and to change all with the same command you can click on common, so that all the metal chain pins are changed to metal pins. Could try to attach this. Now you can resize the PR boundary. The bind key is yes. There is some misalignment here. Adjust that. Make sure that you don't have any kind of misalignments. So you can draw some extra metal here for VDD, and similarly for VSS. To resize it, here we can see that the distances are not matched here. So we are in presently in hierarchy, top hierarchy, that is, and I want to get into this this or I can change it to NAND. I want to get into this object that is NAND. You can press the bind key X. Now you can see you are in NAND. It is showing you are in NAND layout. That is you are in editing. Now you can edit the objects in the NAND layout. And I'm trying to make them align. I think this is enough. And to get out of the and to get back to the top hierarchy level, you can press Shift plus B. Don't forget to save. And again, I want to get into this layout. I want to change the instances. Now I'm getting into this again. To come out, Shift B. You can see layer by layer. In this, we can see some irregularities. You need a poly extension of 0.2 enough. That's enough. And this is what is extra. You can resize it. Similarly, this also. And below also. It's fine. Size is fine. Now we can save it and get back. Now we can see we have some kind of notches here, extra metal drawings in both the layouts. You can change them also. Try to not to have any kind of notches. Save it. And this layout we have many notches. Try to get rid of all the notches, sorry. And also we need to know that this we are connecting it this the output of NAND is getting connected to inverter. So I'm coming into top hierarchy again, and in this I'm editing like we always try to make it a straight connection. And here in top hierarchy level, if we consider now, since we have a DRC constraint, we made some extra width of metal to get minimum area of 0.2. But now we need not to have that constraint since we are connecting this both in top level. So what you can do is So this you can save, can come back, and top level, try to align these both. I think these are not aligned properly, so I can align them. So this is enough, and we have to connect this both or this also. And I told earlier the metal width you have to change to the metal width. The pin width also should change, and try to align the pins to any of one. You have to change this also. Here in this instance also you need to change this width. In earlier video I did not change it. Sorry. Can save it. To remove all the measurements, the bind key is Shift plus K. Now we have few options like annotation browser. Through this we can see any kind of incomplete nets we have or not. So sometimes it will not take this kind of connections in the internal level since, but we can neglect this since we can see that we made the connection properly. But in top level we did not make this net connection, so it is showing this like this, and also the pins are not overlapping, that's why it is not showing like that. If I draw a new metal over this, that will not be shown in the annotation browser. You can see. See, now you cannot see that kind of. So it considers only top level connections. So now we need to make annual connection. You can see some kind of notches here. Now we can draw big annual. You can see there should be no notches in between. Here we drew some extra annual in but it's fine. Yes. Now you can run the DRC and LVS. First we need to run LVS. So the LVS is ran with no errors. Now we can run DRC. You need not to worry about this. This is not just name of the run. You can change it, but it doesn't change the directory of the file. It is just name of the run that we are making. This name. So we have few errors. So we can see like to not have this kind of errors. Can point this. We can do one thing. We can delete the tab connections in the lower hierarchy. Yes, that's sorry. This only. And you can save it and get into top level connection. Now you can make a big PAP connection with a 5 that is supposed to have this. You can have some bigger feet. So now you can run the DRC. So thank you. We completed this session, this lecture. Thank you.